In today's lecture, we will be discussing the parse tree. So basically, the parse tree plays very important role in checking the ambiguity of the grammar. The context-free grammar which you have designed, if you want to know or if you want to check whether it is ambiguous or not, so that can be identified well with the help of uh, parse tree. So parse tree, you can say it is nothing but it is a process of string derivation. So when you have an input string, so that string you can derive with the help of parse tree, and or it is also called as a derivation tree. And there are two types of derivation. First is the leftmost derivation and another is the rightmost derivation. So here you can see this example. Here you have a production rule. This is the example of leftmost derivation. S derives AB or BA. So in case of leftmost derivation, the non-terminal which come first from the left side, it gets expanded first, and that is the reason it is called as a leftmost derivation. So if you could see this, S produces AB or BA, then you have this another production. S produces ASB AAB and B produces BSA BBA. And now you have this input string W is equal to triple A double B A triple B and A. Now you have to derive this string uh, using leftmost derivation. So this is the grammar, context-free grammar, which is given here. Three production rules are there. And you have to check whether this particular string can be derived uh, with the help of leftmost derivation using this context-free grammar or not. The string which is acceptable by the grammar, which we will call that it is a part of a language. So all strings which are derived from the grammar are the part of that language. So it means you can imagine that the way we have designed the rules for digit, for a letter, for integer, for float. So if you are presenting any integer constant, float constant or variable, and if that variable, the string which you are considering as a variable, and if that string is accepted by the production rule or a context-free grammar which denotes the rule for valid variable, then we can say that that variable is accepted by that variable name is accepted by the language. If you have some constant and if integer constant, and if that integer constant follows the rule given in the production rule for integer, then that integer constant is acceptable by that language. Same is the case with the float constant. So likewise, you can give the rule for uh, arithmetic expression for design, for loop, for if statement, and you can give input as a actual if statement, and if that if statement follows the production rule for a if statement, then we can say that if statement is accepted by the language or it is syntactically correct. Okay. So this is the leftmost derivation. So with the very first production, you can see here, we have S produces AB and S produces BA. So this first part, first production rule is used here. So yeah, before we will go, I want you all to note these three production rules so that it will be easy for you to understand which production rule is applied. So I'll give some time. You please note these production rules, all three, and also the input string. Once you note it down, let me know. Okay. So now here we have S produces AB. So from the left hand side, you just have to check the right side of the production, and whichever non-terminal comes first on the left hand side, that you should expand. So AB, so B is the non-terminal which you have expanded to ABB. So this B, got expanded to ABB. That is the production rule given in your context free grammar. So B get expanded to ABB. So you could see here this B, it get replaced with ABB, right? And this A is placed as it is. See, this A is placed as it is, and this B get replaced with ABB by applying this production rule. Similarly, you could see this is your start symbol. So this S, it get expanded to AB, and then B get expanded to ABB. Now, again, when you will parse it from the left hand side, you will realize that this is the B which comes first from the left hand side. So again this B, it get expanded to ABB. So these two A's are as it is. Then this B, it get replaced with ABB, and this B is kept as it is. So accordingly you could see that this we have these two A's on the left, these two A's on the left side of your parse tree. You can see these two A's. These are nothing but these two A's, and this B, it get replaced expanded to ABB. You could see it is ABB, and then again you have expanded this B to ABB. So this B, it got expanded to ABB likewise. Then next, this is B, that is expanded to B. So you could see here it is expanded to B. So I guess this expansion you can see, and which production rule is applied for the expansion, that is mentioned here. And you can see as per this expansion, the parse tree is also derived. So this is called as a leftmost derivation tree, because this tree is derived by parsing the leftmost non-terminal. And here this is leftmost derivation, and this you got by expanding the leftmost non-terminal, the leftmost non-terminal. And you need to expand it so that eventually you should get this string. If you're not getting the string with this particular production rule, if you are starting rule, you are applying A, B. This starting rule you are applying, and then you are applying this sequence of production rule. But if you are not getting the final string with this set of expansion, then you can try another expansion. That is, if it is not working with AB, then you should start with BA. But you have to make a guess that if it is in input string, if you have first A, so that first A you are getting either from this AB, or you are getting it from AS, or you are also but A, it is already there, so there is no point in expanding. So you have to expand in, you have to choose the production rule in such way that you will get the non-terminals given in the string. So you should make a guess what can be used for the expansion, and you should always start with the non-terminal which is acting as a start symbol. So here usually if start symbol is not given, then the non-terminal in the first production rule, the non-terminal which is on the left hand side of the first production rule, is act as a starting symbol. I said the non-terminal which is there on the left hand side of the product, left hand side of first production, that is acting as your start symbol. So as a start symbol is not given, so in the first production rule you can see S is appearing on the left side, so that is the reason S is your start symbol, and from here you can start your expansion. So this is how you will get your leftmost derivation. And another type is rightmost derivation. Here again the same production rules or same context free grammar is used, same input string is used, and only the difference here is you need to expand the derivation uh, from the right hand side. That means the non-terminal which is there on the rightmost side, that you should expand first. So as in the first production rule, you can see there is only one non-terminal. So there is no question of whether it appears on the right hand side or left hand side. So you have expanded it using this ABB production rule, and you got this. Now in this right hand side of production, you will see that you have two non-terminals, but because it is a rightmost derivation, you should expand the non-terminal which is on the rightmost side. So that is the reason this the B which is in bold, you can see. So that is expanded first. This B is expanded first. So here also this B is expanded, then S, then A. So from right hand side you have to process and you have to check whether which non-terminal come first, and you should proceed to expand that non-terminal to get the final input string. And similarly, depending upon this expansion, your parse tree will also, you can build your parse tree. Now here you can see that in case of leftmost derivation or in case of rightmost derivation, same context free grammar is there. If you could see here, the same context free grammar you will see here. Same input string is here in the leftmost derivation. The same is used for rightmost derivation. The parse tree which you got in leftmost derivation, you will see that the same parse tree you are getting in rightmost derivation also. So for same context free grammar, for the same input string, if you are getting the same parse tree in leftmost derivation as well as in rightmost derivation, then we can say that the grammar is unambiguous. But if you are getting uh, leftmost derivations parse tree, and if that parse tree is different than the rightmost derivation tree, then you can say the grammar is unambiguous, and you as a compiler designer or a rule designer, you need to reconstruct your grammar. So this is how the ambiguity of the grammar can be checked. So see here, for unambiguous grammar, leftmost derivation and rightmost derivation represents the same parse tree. For ambiguous grammar, leftmost derivation and rightmost derivation represents different parse tree. Take a note of this practice problem, and uh, for this particular string, you have to find the leftmost derivation, rightmost derivation, and parse tree. And in the same another problem also, you have to do the same. And finally, you have to come to the conclusion whether the grammar is ambiguous or not.